In these slides, I will present the lens calibration plugin, the way it works, the results we get, and the precision we get once we calibrate the camera. First, the plugin functionality is as follows. It obtains the field of view of the camera, the horizontal and the vertical field of view. It obtains the nodal point, and it also obtains the lens offsets, the X offset and the Y offset. And it does so for any zoom and focus configuration in the camera. After we get a calibration for all that pairs of zoom and focus, we calculate some curves and we bind the zoom and focus values to the camera parameters. This is one of the zoom curves that we get after a calibration. The plugin requirements are as follows. We have hardware requirements and software requirements. First thing, we need a frame grabber because we capture the camera images and we analyze them. And we need also super bright blinking LEDs, one red LED and one green LED, that we use in order to get where some points in the scene are captured by the camera. On the software side, we need the camera to be registered. We need to know where the camera is exactly as it pans and tilts, and to do so we use the position calibration plugin. This is a picture of one of the LEDs we use. This is the red one. Well, now we need to set up the eStudio before we start lens calibration. What steps do we have to perform before we start? Well, first we need to load and configure the camera V-in plugin. We need also to configure the camera tracking plugin. We need to register the camera with the position calibration plugin. And finally, we need to bind the field of view, horizontal or vertical, it doesn't matter, to the zoom, or if we are calibrating zoom and focus, we can bind it with a XY bind and use zoom and focus values. Well, now, how to set up the plugin? First thing is to select the camera we want to calibrate. Second thing is to select the V-in texture we want to analyze, because the plugin analyzes images in order to know how the lens is behaving. Next thing is to select the LED colors and their positions. And finally, we need to set the number of zoom and focus positions that we want to calibrate. These are the configuration tabs in the plugin. The first one is related to the source image and the camera. In here you select them, and the plugin, after you select the camera to be calibrated, it says you, okay, this camera is banded, it's just binded to the zoom encoder, but it can work with it. If you select a camera that is binded to zoom and focus, it will work again, and if you select a camera that is not binded at all, the plugin will complain. The second tab is related to configuration, to the LEDs configuration. As you see here, you can configure 3 LEDs. We are now using red and green LEDs, and you see here where each LED is positioned. It is very important to position very well these LEDs. I mean, to know very exactly where the LEDs are placed. After you see the grid resolution, in here we are telling the plugin that we want to calibrate 5 zoom positions and 3 focus positions. That means 15 pairs of zoom and focus, and with every calibration we will prepare a set of curves that in fact is a surface. In here you also see the info beep and the verbose checkboxes that allows to to print on the MS-DOS shell all the warnings or things that happen during calibration, and the info beep just tells you when you capture any camera position. Well, now the calibration process starts once you press the start button. Once you do that, every single step has its own help, and the plugin tells you what to do at any moment. For example, it says you move the zoom and focus to their limits, or set zoom and focus to these values, or take more captures by panning and tilting the camera, or when you finish, press transfer to set camera parameters. The last tab is related to errors, and after each zoom and focus calibration, you can go to that tab and check the maximum errors in pixels that you have for that configuration of the camera. These are the calibration process tab and the errors tab. The calibration process tab has every button and instruction that you have to follow in order to calibrate every pair of focus and zoom in the camera. And as you see here, you have two slides that tells you where the zoom and focus are placed. At the bottom of the tab, you have here instructions. You just need to come here and check what to do at any moment. You have the next button that allows you to go through the calibration process, and once you finish, you have the big transfer button that sets all the parameters in the camera. The results tab has for any zoom and lens node, you can come here after you calibrate them, and you can check the lens offset, the field of view vertical and horizontal, all the parameters that you get in this calibration, and also the errors you are having, the maximum error you are having in this calibration. We have done different kinds of calibrations with real cameras and with virtual ones, and we see that typical errors are of 6 pixels or so. It usually happens when you close the zoom. We are already working on some improvements in the plugin. We want to include radial distortion. We want to improve our graphical user interface, and we want to simplify it. And also we want to prepare a wizard that will be overlaid on the pipe, so the cameraman can do a calibration on his own. This is a map of errors that we get when we try to calibrate a camera with lens distortion. Our plugin by now is not correcting lens distortion, and that's why we get so big errors. If you analyze it, you will see that errors are what you can see if you compare crosses and pluses. You get some distances that if you analyze them, you will see that they vary depending on the distance to the center of the image. We have prepared a chart where you can see how these errors behave. In a perfect calibration, we won't get any error, and all these red and green points will fit the blue line. In this case, because we have that radial distortion, we get some kind of curve that we think it is a parabol that once fit, we will be able to simulate lens distortion. That's our work at the moment. We expect to have new results maybe in 1 or 2 weeks. And that's it.